Julia, and in this video I will talk about the Butterfly Classifier application. But first of all, let me present my team. This is Wael, this is Dean, and finally me. In what follows, I would like to give you an overview of our application. To do this, I will use the proof of concept website we have created during the last weeks. Our main client is the Natural History Museum. However, as of now, the only direct contact we had with them was through Dr. Gabriel Brasto from UCL. The application we were asked for aims at detecting the species of different butterflies using a machine learning algorithm over a huge butterfly collection database. The main functions that the application must have are importing a picture, cropping a picture, and uploading a picture to the server. In order to give you a broader idea of how the application must work, I will use the user interface design idea we have created. So, the first function is the import. A user can import a picture from either the phone's gallery or just take it directly using the camera. After they are happy with the image they have, they are required to crop it. This happens because in order to get a very accurate answer from the server, the dragging box must be as tight as possible around the butterfly. By pressing crop, the image is cropped, and then the upload takes the image to the server where it is processed and the answers come back to the user. The next thing I will consider is the group management. The way in which our group approached this project was highly democratic. All decisions were made together after thoughtfully argumented discussions over several matters that appeared over time. Regular team meetings took place and the contact between us existed permanently throughout Facebook and Dropbox. For the coding part, a Bitbucket repository was used. Internal deadlines were set up and all members took care to meet them, improving our overall efficiency. In order to get to a larger image of our group management strategy, have a look at our bi-weekly and meeting reports, which can be found on our website under the Group Progress tab. In what follows, while we'll present the research and the experiments made, we'll provide a live demo of the prototypes and we'll talk about our future plans.
Here's an overview of the conclusions we made out of research this term. We'll target two operating systems, Android and iOS. Choosing these two is mainly due to their popularity. We'll build a common app in HTML5 and JavaScript, and we'll create a web view in both Android and iOS, which will contain this common app. They will also contain small functionality, probably image importing from the gallery or taking pictures out of camera. There is one advantage for this approach, which is that we'll be coding only once. But also there is a disadvantage, which is we have complicated browsers, inconsistent responses to identical events, which complicates the coding a bit. For the libraries, I will be using Cafe library for the image classification. This library was suggested by Dr. Prosto in our first meeting. We'll also use jQuery, which is the most well-known JavaScript library. I will use HTML5, CSS, and JavaScript to implement the common app. And we'll also use Java and Objective-C to implement the native application that will create the web view, which contains the common app. PHP will be our main language in the server side. Now, with regard to the source control, our main reason for choosing a Bitbucket instead of GitHub will be actually is because our clients insisted that we have a private repository instead of open source repository, and Bitbucket provides unlimited number of private repositories, unlike GitHub. Um, we'll be using NetBeans for the HTML5 development, Android Studio for the Android development, and Xcode for the iOS development. We'll be using Ajax uh, to send requests and get asynchronous responses from the server. We'll be needing that in the results page of our client side. Uh, our app is structured into 4 layers, 2 on the client side and 2 on the server side. On the client side, we'll have a native layer, which will be written in Java or Objective-C. This layer will be mainly a web view containing the cross-platform layer, but also we'll be using it for anything that is complicated or impossible to implement in the HTML5 JavaScript syntax. This will be containing most of the functionality of the client side of our application. Now for the server side, we'll have a layer in PHP which will take requests from users and run the backend application and then responds back to the users. The backend application is the core part of our project, which will be the image classifier. It will take an image and return a probability distribution, which means a probability distribution for this image belonging to which of the butterflies species. Moving on to the prototype. We chose to do our prototype in pure HTML. The reason for that is to show that it is feasible to do the client side of the application, mostly in HTML and JavaScript, independently of the platform. So in our prototype, we show 3 functionality that is required in the client side. The first one is importing image from a gallery or choosing it directly from camera in case of a phone. Second of all, cropping the image, and finally uploading the image and receiving a response successfully. There are a few images here taken, but we do a live demo. So you pick an image, say this one. Okay, you go to the second page, which asks you to crop the image. You could zoom out and then scroll and place the cropping box around the butterfly. Then press crop and upload. This is the displayed cropped image, and you will get a link where it is uploaded to the server. So this is the end of the prototype. Finally, our plans for development in term 2. We'll start term 2 by implementing a fully functional, user-friendly application based on the prototype that we showed in the proof of concept. The application will be in both Android and iOS, and we'll test it for consistency of behavior among both the platforms. At the same time, we'll be implementing the server communication layer, which communicates with the client side of the application and runs the backend application. Then we'll move to the backend application implementation, which is a convolutional neural network that uses the museum's dataset uh, to get uh, an image classifier. Then there are also two non-strictly requirements in the project. Um, the first one of them is to place a cropping box around the butterfly in the image automatically. We'll try to use automatic detection algorithms to do that. Finally, the dataset provided by the museum is professionally photographed. The images have clear backgrounds, high resolutions, um, which is not the same type of images that we are expecting to get from users. So we try to do a pre-processing of some of the images to substitute the background with um, natural views. We'll also try to change the angle of the butterfly with respect to the camera and the angle between the two wings of the butterfly. That would be our plan for term 2. Thank you.